Okay, for question 7, this is another conceptual question for a vertical constant acceleration freefall problem. So we're ignoring air resistance. So we drop a small ball from rest, and then when that ball is dropped a distance of 1 meter, you drop a second ball, also from rest. Which of the following is a true statement, but the distance between the two balls is the fall? So just drawing maybe a small picture. Maybe this is a ledge or something, and this is the second ball, and ball 1 has already dropped 1 meter, and ball 1 will have a certain speed. Now we can figure out the speed ball 1 has after dropping 1 meter, assuming it's dropped, we're told it's dropped from rest. So the speed of ball 1 at this particular, after dropping 1 meter, would be the square root of 2 times g times delta y. In this particular case, we'd have 2 times 9.8 times this 1 meter, and this works out to be about 4.4 meters per second. It's not necessary to calculate the speed, but it's more for the context of the question, in a sense that ball 1 will have some sort of velocity after falling 1 meter. And this is just adding a little bit of quantitative information. So this means that, and then once ball 2 is dropped, they both have the same acceleration, but for every instant after, in a sense, or for every instant once ball 2 is dropped, ball 1 will always be moving at a speed 4.4 meters per second greater than ball 2. They both speed up at the exact same rate, at the rate due to acceleration due to gravity. And that means that ball 1 will always be moving faster than ball 2. So for any equal time interval after this instant ball 2 is dropped, ball 1 will cover a greater distance for every equal time interval. So this 1 meter distance between the two of them at the beginning, that 1 meter distance would have to increase because ball 1 will always be moving faster than ball 2, of course, until they both hit the ground. But while they're in the air, the spacing between the two balls would have to increase, because, for that again, repeating for that reason, because ball 1's always moving faster, which makes B the correct answer. You could sort of maybe add some graphical, some graphical data to the question. If we were to plot a y versus t curve, of course, this speed would of course be in the negative y direction. So if we think about ball 1 as if this is the initial position of ball 1, and ball 2 if this is time and this is the y-axis, and we're assuming if I accept this to be y equals 0, then what ball 1 at this particular time, if I set time 0 to be when ball 2 is dropped, ball 1 will already have to have a downward sloping tangent at this point, because it already has a speed at this point, and then it will sort of increase downward. Where ball 2 has to start with a horizontal line, so its parabola is not the same. So I'm not drawing it super accurately here. What I'm trying to indicate is that the distance here of 1 meter gets larger and larger as time goes by. If you were to draw this accurately in Excel, this is what you would find, is that the spacing between the two balls has to keep increasing as time passes by, due to the fact again that ball 1 is moving at greater velocity at all times once ball 2 has been dropped.